through it. I'm going to take you through, and unfortunately for a question like this, what I'm about to do, I didn't give nearly enough space. So when you do it on your own, and I don't know why this particular notebook is framed like this, but I'm just going to live with it for now because I don't want to waste time. But I didn't give nearly enough room. So when you do this on your own, if you want to try all the different approaches for working through these problems, separate paper might be the best way to go. All right. So the directions, this is create a table of values, axis of symmetry, come up with a vertex. With the vertex in the middle of the table, so that's an important component, following directions, I mean, that's the obvious thing, but putting the vertex in the middle of your table, right? Then graph the equation and state the solutions of each equation. So basically, everything that we were talking about yesterday. So personally, I like well, you know this. I've beaten it to death a little bit. The standard form approach for finding the vertex, all right? Some people are on board with that. Some people are like, I don't know why you like that so much. I think after we get through this problem, you'll see why, all right? So y minus 2, poor quality y, is equal to x squared minus 3x. We're going to complete the square. All right. You don't have to complete the square in your head. You have calculators. But at some point, it might be a couple years away, but at some point you will be able to. So if you know it's going to happen eventually, so that's telling you that you are capable of doing it in your head, why not try to do it in your head now, see if you can kind of, make it happen sooner than maybe history would have recorded otherwise. All right, so I'm going to take my b value, cut it in half, square it, divide by the a value. All right. So my negative 2, cut it in half. Well, that's going to create a fraction. I don't want to deal with that. So I'm just going to leave it as, I don't want to deal with a decimal. I want to leave it as a fraction. So negative 3 over 2 is negative 3 divided by 2. I'm just going to leave it as negative 3 halves. Square it, what do I get? 9 over 4. The negative squares away. Divide it by the leading coefficient of 1, not going to change anything, so I'm adding 9/4 to both sides. All right, so we're taking negative 2 and adding to it 9/4. Oh, I thought it was a solid hand raise volunteering to answer the question. Oh, cool, yeah. 1/4, awesome. Thank you. All right, so negative 2 plus 9/4 gives us the 1/4. And so all we have to do is factor the right-hand side, and it should be a perfect square trinomial. That's the whole point of this. The whole reason we do this is to get it to be a perfect square trinomial. If it's not a perfect square trinomial, I mean, the simple thing for me to say is you did something wrong, but the thing that you did wrong was in your b over 2 squared divided by a computation, right? Or there was a GCF that you didn't factor out. In this case, the leading coefficient was 1, so there was nothing to factor out. All right, so what are my factors? X minus 3 over 2. Boom, shakalaka. All right, so solve it for y in terms of x, and we have y equals x minus 3 over 2 squared minus 1/4. So from this, we have our vertex. I like to state the vertex first. If you use the proper notation, regardless of the way the question is asked, there's let's state the axis of symmetry, then the vertex, then the whatever. As long as you use the right notation, you can put it in any order you want. All right. So V for vertex. What is my vertex here?
3.
Right. Yeah, so as long as you remember to keep the sign of the thing on the outside, that -4th, keep that sign. That's the one that stays put. The other one is the one that gets changed. So in the parentheses, gets reversed. the one outside the parentheses is going to remain the same, then you'll have your vertex, which leads us to our axis of symmetry, A of S, x equals 3/2. Now, we've been talking about the regions, and those people all year long, and how the tests are designed to be preparations, really, for the regions. The way the regions requires us to grade is by a very rigid set of guidelines, but within their intended rigid set of guidelines, there is room for a little bit of flexibility, but not much. On a test, when I see A of S, I know what you mean. All right. Depending on how they phrase the grading criteria on the Regents exam, they may actually flat out say, do not accept any abbreviations. All right. So when we get closer to the exam, there's a lot of things that I'm gonna clarify in terms of what you need to write and what you don't need to write. The one thing I will emphasize as we move closer is just try to stay away from abbreviations and just write, if you're in doubt, just write out the entire word, phrase, term, whatever. All right, but I look at it this way. If you can abbreviate for 10 months out of the year and you have to sacrifice one day by writing out an entire word, I think we can live with that trade-off. All right. So we have information about the vertex. They're telling us to make a table of values. All right, that table of values. Now, and the only reason we're making a table of values is because they told us to. All right, so that's something else to keep in mind. The instructions are going to dictate for us what we need to actually do. But if the instructions aren't provided, you do it any way you want. So we know that the vertex is at 3/2, -1/4. So 3/2 is 1.5. So 1.5 boxes to the right. If I don't rescale the graph, it's assumed to be going by ones. So this really is 1.5 boxes and to the right, and then down I'm gonna go about 1/4 of a box, and that'll be my vertex. All right, that information goes right in the middle of your table. The rest of the information from your table you can get right from your calculator, but let's kind of put that on hold for a second. Really, in order to graph a parabola properly, you only really need 2 points. As long as one of them is your vertex, that's really all you need. The problem is these directions are telling us that we need more. All right, so one piece of information that we have is the axis of symmetry and the vertex. So that's taken care of right here, right? The axis of symmetry tells us what the graph is symmetric about. So you don't have to draw this dashed line, but I'm going to do it anyway, because this really is the fold in the graph that matches one side to the other. All right. Another point that's pretty obvious would be the Y-intercept. All right, the Y-intercept you could always get from your original general form quadratic. All right, it's the C value is your Y-intercept, and the reason that's the case is because the Y-intercept always occurs when the X value is equal to 0. All right, so what I would do is I would replace each X value here with a 0. And when I do that, I would just be left with whatever the C value is. So I know that the Y-intercept is here at 2. All right. Because of symmetry, I now know a third point. That's why I was saying you only need 2 points, because if you know that there's symmetry, you can infer a third point. So this red point is 1.5 boxes away from the dashed line. So just go 1.5 boxes the other way, and you have a third point. All right. So I could actually draw the curve now, and it would have really the important points. But they also want the solutions. They call them the solutions, we call them the roots, all right? So those roots are the other important points. So what we would do is use your favorite technique, which, yeah, I'll say this hoping it's the truth, but I'll present it as if it's sarcasm. Your favorite technique, which is, of course, completing the square to solve the quadratic, all right? So hopefully it's the truth, but if it's not, then I was just being very sarcastic, all right? Maybe after what I show you now, it will be the truth. I just want purple, okay. So right in this step here, like I said, not nearly enough room, right? We've already completed the square to get to this part of the problem, all right? So what we would need to do is replace the y with a 0 because, and I'll make a note of that, replace y with 0, at which point you get 1/4 is equal to x minus 3/2 squared. All right, we replace the y with 0 because a y value of 0 gives us a point on the x-axis. All right, x-axis is also the line y equals 0. All right, so replacing an x value at 0 puts you on the y-axis. Replacing a y value at 0 puts you on the x-axis. All right, so thinking about the completing the square process, you had to do the b over 2 squared divided by the a value, and then you had to do, you know, move some stuff over, this, that, the other thing. If you're going to the standard form, you wanted to get y equals, but if you're actually trying to solve for x, the next step in the process would be to take the square root. Square root of 1/4 is what? Plus or minus 1/2. So we would have x equals 3/2 plus or minus 1/2, which would make x equal, if you think about it in terms of just the individual calculations, 3 minus 1 is 2, divided by 2 is 1. 3 plus 1 is 4, divided by 2 is 2. So I have the y-intercept, which by symmetry gave me an additional point. And now I have two x-intercepts, so I can plot those. I'll just, I'll highlight them so that it's easier to see, I think. These two bad boys. 1 and 2. All right, so now I have my 5 points. I can create the graph, just a smooth curve through that parabola. Now, these points you could have gotten from the calculator using the table of values. The problem is they're not, while they will be points on the graph, they may not necessarily be x-intercepts and y-intercepts. All right, the techniques that we just used guarantee that the points that we come up with will be x and y-intercepts. All right, so it's kind of like, oh, why did we just do this if we could just use the calculator? Well, the calculator is not always going to give you the right kind of numbers. It'll give you numbers, but it might not be the right kind of numbers. All right. So, nice smooth curve through all 5 of these points. Nice shaky curve through all 5 of these points. And that's your parabola. All right, but let me show you really quickly on the calculator. You know, we could have gotten all these points. It would have been great. But aside from like the learning part of it, which, you know, it's, you know, that has its place in the conversation also. This is one of those things where the calculator can only get you so far, all right? So you still need to know your vertex. sometimes the calculator can tell you the vertex, right? Flat out. The problem is, since this is a fractional vertex, you got a problem, all right? It's not gonna show up in your table. So when I hit second graph, I have a table of values, but it's only changing by integer values. Now you could change the change in table. You can make it go by half units, quarter units, eighth units, but it's a kind of chicken and the egg kind of thing, because how do I know to make it go by half units unless I know the answer is a half unit? What if it's a quarter unit? What if it's a 16th? What if it's like just an irrational number, you know? I mean, that's unlikely, but it's possible, all right? So that's something to keep in mind. Also, you know, we're not gonna get that full symmetry in the table if your vertex is not an integer value. So looking at my table here, I want to get it so it matches up top and bottom, but you see it's almost going to match up. You see I got a 12 there, a 12 there, a 6 there, a 6 there. But where's that middle value? That middle value seems to be directly in between 1 and 2. And I got to tell you, I lose my mind every time I see this. People do this on tests, and if you do it, it demonstrates zero understanding of this concept. People will just ignore everything I'm saying here and plot these points, because that's what the table said, and they'll draw this graph. If you draw this with a flat bottom, it means that you have not been listening to a single word I said throughout the entire unit. All right. All it means is that you have been. This conversation took a big turn. It means that you have been just waiting for me to tell you what to type in the calculator and then just writing stuff down. All right. That is not a parabola. I don't even know what that is. I mean, it's something that we'll learn later. It's not a single function. It's a piecewise function, I guess. It's yeah. I mean, it's a very practical figure. I mean, it's useful in everyday life, but it's not a parabola. All right. So that is what you would get from this. You still need to do the algebra to come up with your axis of symmetry and vertex. All right. So if you have to do all of this stuff already, why not do these extra couple of steps to come up with the exact value of your turning points? Your roots. Besides, maybe those roots are irrational. You're not going to get them from the table anyway. Turns out the roots here are 1 and 2 because they have corresponding y values of 0. The one thing that you'll always be able to get from a table is the y-intercept, because the y-intercept is the y value that corresponds with an x of 0. So you just have to look for x of 0 and the y that goes with that. That's easy to pull from the table. You can always get that from the table, but you could always get that from the equation itself, just the loose constant. All right, so you're limited in what you can do in the calculator. The algebra is what's going to get you there. All right. Now, that being said, I will show you very quickly a little trick to help you get the axis of symmetry. And then from there, you can do what you want. The trick is not for everyone, but if you like it, it's yours, but it's not an algebraic approach. All right, so think multiple choice, think any question that says, you know, do it any way you want. But if it says you have to do it algebraically, you would not be able to use this technique. So, in the math menu, in your calculator, there's a function that says f min and f max. Okay? So, what that's giving you is the minimum and maximum values for a function, but only the x values that lead to the minimum and maximum values. So you'd have to know whether your parabola has a minimum or a maximum. This parabola has a minimum because it opens upward. So I would select option 6. Then I would type in the function itself. All right, so since I've already typed in the function into y1, I would just use alpha trace y1. But then you also have to indicate what the variable is. So this is where people kind of start losing it. They're like, yeah, forget it, I'm not gonna do this. So f min y1, type in x, and then you have to type in the domain. Okay, so I just typed in something large like negative 100 to 100. Because the interval that contains the minimum or maximum for the problems that we work on are always going to be in that interval. Okay, so something like that. And it'll spit back the axis of symmetry for you. All right. The problem is if you select, for example, F max when it's supposed to be a min, then it's not going to do the job for you. All right. So you have to know the orientation of the parabola, but that's easy because you're typing in the function to begin with in your y1. So why not take a look at the picture? All right. It's opening upward. So you know it's going to have a minimum. Then once you have that, then you type your F min, so math, and then find the option that says F min. So it's option 6. In my calculator, it might be different in yours. Then type in Y1, which is your alpha trace. Then the variable that's used in the function, and then an appropriate domain. And it'll give you your axis of symmetry. So you can get it that way if you want. All right. And then if you want the y value that goes along with that, you could evaluate it because remember, I've been leaving this sign up all year, honestly hoping that people would look to this sign during tests and say, wait, how do you find y given an x? I know the x value. How do you find the y that goes? Oh, there it is right there. Type the equation in y1, select alpha trace y1, and then type in your x value. So if I wanted to find the y value for this vertex, alpha trace y1, and then type in the 1.5, and that'll give me my vertex of negative 0.25, which is the negative 1/4. Right? So I can get my vertex using this technique. Again, it's not algebraic. So if the question says you have to do it algebraically, it's not going to fly. But it's a way of getting an answer, and that's good too. All right. Okay, so I talked longer than I wanted to, but I thought this was all important, really useful information. So,